Okay, so today or this week we've been talking about combining like terms and distributive property. And I introduced distributive property Tuesday, and you had a little practice Wednesday. So we're going to practice some more today, and we're going to put in another little aspect to the distributive property and simplifying these expressions. So, but first we're going to go over distributive property some more because it was just introduced Tuesday. So we need to practice that a little bit more, and we'll be practicing through next week. Now, right now, I have a test planned for next Friday. So we will be working on all of this through next Thursday, and then you will test next Friday at this point. Okay, so let's go over distributive property first. So let's say we had 3 times 6x plus 7. Okay, so we said distributive property, you could go ahead and add these together, but we can't because we don't know what this x stands for. But we can simplify it even further. And I also want you to notice that this is an expression because there is no equal sign. We cannot solve this expression because it is not solvable. We don't know what x is. And we will be getting to equations later. But we're going to go ahead and remember my quirky way of doing this distributive property was to trick or treat all the houses. And I said that the 3 is your trick or treater, and it wants to go to each house or each term so it can get candy from each house. So we're going to distribute the 3. And we talked about when you order something, you get an email that says, hey, we distributed this product to your house. So it's going to each house. We're going to distribute the 3 to each house or each term. So this would be 3 times 6x. I would bring down my plus sign, and 3 times 7. And I was telling the people in class that I don't do this when I'm working these myself. I don't do the parentheses. But when we're learning how to do it, it helps us to visualize exactly what we need to do by going ahead and writing it out. So I would like for you to write it out in parentheses. And if you get the wrong answer, it's easier to go back and see, okay, this is where I messed up, because I didn't write the right numbers here, or I left my variable off, or whatever the reason is you didn't get the right answer. So 3 times 6x is 18x. Bring down your plus sign, and 3 times 7 is 21. Now, I'm going to check to make sure that I don't have any like terms, and I don't because this has an x and this one doesn't. So this regular looking number is actually called a constant because it is going to be 21 no matter what. This 18 is not a constant, it is a coefficient because whatever x is will be multiplied times 18. So 18 will not stay the same thing once we know or if we know what x stands for. But at this point, all we know is 18x plus 21, and that is the most simplified way we can write this expression. Okay, I'm just going to draw a line across and we'll try another one. So let's do 7 times 2y minus 6 plus 5y. And I would write this out. Again, I need to distribute the 7 to each term. So 7 times 2y. Bring down your minus sign. 7 times 6. Bring down your plus sign. And 7 times 5y. Okay, so now I can multiply each set. 7 times 2y is 14y. Bring down my minus sign. 7 times 6 is 42. Bring down my plus sign. And 7 times 5y is 35y. Now I need to check. Do I have any like terms? I see that I do have like terms this time because I have two numbers with the variable y. So I see that this is a positive 14y and this is a positive 35y. And positive 14y and positive 35y have the same sign, so that means I'm going to add and I'm going to get 49y. I don't have any like terms with negative 42, so I'm just going to bring that down. So 49y minus 42 is the most simplified way I can write this expression. That looks a lot less scary than this. Okay, let's try another one. This time I want to have a negative number on the outside, and that changes things a little bit. 4g minus 6h plus 12 minus 5g. Okay, so this time I'm not going to write my parentheses, and I'll tell you why. Because it gets a little confusing when you're multiplying a negative and then bringing down these signs. So I am going to write the parentheses, but I'm not going to be bringing down these signs, and I'll show you why I think it works out better. So you are going to you are going to multiply each term. So I'm going to go ahead and square off each term. This one is positive 4g. This one is, remember these are our houses, negative 6h, positive 12, and negative 5g. So let me show you how this works. So negative 2 times positive 4g, negative 2 times 4g. I'm not going to bring down that sign because it's going to go inside my parentheses. Negative 2 times negative 6h. Negative 2 times positive 12. And negative 2 times negative 5g. Okay, so why did I do this? Well, let's watch. Negative 2 times positive 4g is negative 8g. So see, I already have my signs here. Negative 2 times negative 6h is positive 12h. Negative 2 times positive 12 is negative 24. And negative 2 times negative 5g is positive 10g. Now, if I had done it like I do these up here, I would have had negative 8g minus minus positive 12h. Anyway, there would have been a whole bunch of negatives next to each other, which would have been pretty confusing. Actually, I started this video over because let me show you how confusing it looked. See how this looked when I brought down my signs? See, that was the negative brought down and the positive. Well, then I had all these, and they would have turned into positives. So to me, I felt like I needed to show you this instead of bringing those signs down. So, and we can do the other ones like that also. So we're left here with negative 8g plus 12h minus 24 plus 10g. So now we need to see, do we have like terms? And I see that I have two terms with the variable g. So negative 8g and positive 10g. My signs are different, so I'm going to subtract, and I will keep the sign of the largest absolute value, which is positive. So my answer would be 2G, because 10 minus 8 is 2. 2G. Now, I don't have anything that goes with the H. There's no more terms that have an H, so I bring that down. And there's no more constants or terms without a variable, so I'm going to bring the negative 24 down. And this is the most simplified version of this. Let's try another one. With a negative on the outside. So let's do negative 5 times negative 4 plus 6x minus 2xy. Okay, let's distribute this. So we're going to distribute the negative 5 to each term. So each term includes the sign in front of it. So negative 5 times negative 4. Negative 5 times negative 4. Negative 5 times positive 6x. Negative 5 times negative 2xy. So negative 5 times negative 4 would be positive 20. Negative 5 times positive 6x would be negative 30x. And negative 5 times negative 2xy would be positive 10xy. Now I need to see, do I have like terms? This would be a regular number, or otherwise known as a constant. I don't have any other terms that are just a constant. I see that I have a term with an x. Now 10 does have an x, but it's not only an x, it's an xy. So there are no other terms that are exactly just the variable x. So it has no like terms. And xy also has no like terms. So this is our most simplified version. Okay? Let's try one with a variable on the outside. So if we had 3x times 4 plus 5x minus 4y plus 10. Again, we want to distribute this whole number, and this number involves a variable. So let's distribute that. So it would be 3x times 4, and then 3x times positive 5x, 3x times negative 4y, and 3x times 10. So 3x times 4 would be 12x, and it's positive. 3x times negative, I'm sorry, I don't know what I'm saying. 3x times 5x is positive 15x. 3x times negative 4y would be negative 12xy. You have to carry both of those variables with you. And 3x times 10 would be positive 30x. Now I need to look and see, I made a mistake. This says 3x times 5x, and I only have one x here. But this is x times an x. So anytime you're multiplying an x times an x, it's actually going to be x squared. I'm glad I caught myself. So make sure you go back, just like this one was xy because we multiplied x times a y. We don't know what x represents, and we don't know what y represents. So this was an x times an x, so it has to be x squared. I'm sorry, I made that mistake, but I'm very glad I caught myself. Okay, so now we need to look for like terms. So we have positive 12x and positive 30x. These are alike because they both have a number and the variable x. Only one x. So x squared does not count as a like term because that is not only x, it's x squared. So 12x plus 30x, they're both positive. Signs are the same, so that means we're going to add and we're going to get positive 42x. Do I have any like terms with x squared? I don't, so it's just going to come straight down, plus 15x squared. And I don't have any like terms with xy, so it also just comes down, negative 12xy. So this is the most simplified version of this, or it is an equivalent equation to this. Let's try another one with a variable. So so we can get a little bit more practice, and I hope I didn't confuse you too much on that one since I messed up. Okay, so let's try 4y times 12 plus 6y minus 4x. So again, we're going to distribute the 4y to all of the terms. So we would say 4y times 12. Then we would say 4y times 6y. And then we would say 4y times negative 4x. Okay, so we have 4y times 12, which is going to be positive 48y. Don't forget the variable. 4y times 6y equals positive 24y squared because it's y times a y. And then 4y times negative 4x gives me negative 16yx, or it could also be written as negative 16xy. It really doesn't matter the order, but you can do it either way, whatever makes you feel better, okay? So I'm going to look to see if I have any like terms. I see that I have a y here. I also have a y here, but I notice it's a y squared, so that is not the same. And I have a y here, but it's a yx, so that is not the same. I have no like terms with y. I have no like terms with y squared, and I have no like terms with yx. So this is my most simplified version. Okay, so let's move on to what today's lesson is. So you may also have other terms outside of your parentheses. For instance, you could see 2 times 9k plus 4. And then you may have plus 4k. Which one of these terms are connected to the parentheses? The 2 is connected to the parentheses. There's a plus sign between the 4K, so it is not connected to the parentheses. So you are only going to distribute the 2 to what's inside these parentheses. This is called expanding. So it's expanded because it has plus 4K added on to it. So let's distribute this 2. So 2 times 9K, 2 times 9K, and 2 times positive 4. Okay, so 2 times 9K is 18K, and 2 times 4 is positive 8. Now, I distributed this, but I cannot forget that this is also part of this expression. So this has to come down into my new expression, plus 4K. Now I have like terms. I see that I have 2 terms that have K as a variable. So I have 18K and positive 4K. So this is a positive 18K and a positive 4K. My signs are the same, so I'm going to add. And I'm going to get positive 22K. And I can't leave this out, so I'm going to bring down my positive 8 or my plus 8. This is the most simplified version of this. We'll try a few more and then I'll let you get started on today's lesson. I don't think this is really a hard concept. It's just different the way you see it. And as long as you know what you're supposed to be multiplying in the parentheses or what you're supposed to distribute, then I think you'll be okay. So this time we could have negative 7G minus 2 times 4G plus H. So, what is directly attached to the parentheses? This negative 2 is directly attached to the parentheses. So you are going to distribute negative 2. So, what do you need to do with this? You're just going to bring it right on down because it is not going to be distributed. So we're going to distribute negative 2 times 4G and negative 2 times H. And we're going to get negative 2 times 4G is negative 8G, and negative 2 times H is negative 2H. Now, do I have any like terms? I see that I do. I have 2 terms that have the G as a variable, so it is negative 7G and negative 8G. My signs are the same, so I'm going to add, and I'm going to get negative 15G. And I knew it was negative because my largest absolute value was negative. And then I'm just simply going to bring down the negative 2H. And that is my most simplified version. Let's try another one. This time let's try 2 times negative 4x plus 3 minus 8 plus 5x. Okay? I want you to think, what should I distribute? So I see that this 2 is directly attached to these parentheses. So I'm going to distribute this 2. Now, what am I going to do with these? I'm going to bring them straight down in just a minute, but I'm going to distribute this first because it's on the front of my expression. So I'm going to do positive 2 times 4, so 2 times negative 4. Oh, that's a 4x. Negative 4x, and then 2 times 3. And then I'm going to bring down the rest. Negative 8 plus 5x. Okay? 2 times negative 4x is negative 8x. 2 times positive 3 is positive 6. And I bring down the rest of my equation. Not equation, expression. I'm sorry, I'm really tired. It's the end of the day, and I'm tired, and that's why I'm stumbling over my words. So I now have negative 8x plus 6 minus 8 plus 5x. I do notice that I have some like terms. I have two terms that have x on the end, so I can combine those. Negative 8x and positive 5x. My signs are different, so I'm going to subtract, and I'm going to get 3x, and I'm going to keep the sign of the largest absolute value, which is negative. I do notice that I also have two other like terms. I have positive 6 and negative 8, and their signs are different, so I'm going to subtract, and I'm going to get 2, and I'm going to keep the sign of the largest absolute value, which is negative. So I am left with negative 3x minus 2. Let's do one more, and then I'm going to let you practice. Let's say we have negative 5 minus 4 times 2k minus 6. So these are on the front. This is on the front, so I'm just going to bring it down. But first, let me stop. This is what I'm going to distribute because it is directly attached to the parentheses. So I'm going to distribute this 4. So I'm going to bring this 5 down, negative 5 down. I'm going to distribute negative 4 times 2k and negative 4 times negative 6. Negative 4 times 2k is negative 8k, and negative 4 times negative 6 is positive 24. Now I notice that I have like terms. I have two constants or two regular numbers. I have a negative 5 and a positive 24. So my signs are different, so I'm going to subtract. 24 minus 5 is going to be 19. I think it's 19. And it's positive 19. And I'm going to bring down my negative 8k. So this is the most simplified version of this that I can get. Okay, I hope I didn't confuse you with my end of the day brain fog. If you need to watch the video over again, please do. I'm going to give you a practice sheet. Remember, we'll be practicing this more next week, so please don't freak out if it's a little hard. I know this is hard. And for some of you, it's not. It's really easy and you're really enjoying it. And for some of you, it's a little confusing. And we will get there. And if I say next week that we're not ready for a test, then we'll move it. But as of right now, we're preparing for a test for next Friday. And we've got a whole week to do this and another day this week. So good luck with your simplifying algebraic expressions. And I will see you tomorrow.